Okay, this is a short video going through the function of the electroscope and highlighting what we did in class, day 2 of our electricity unit. So, to begin with, we need to understand what the electroscope is, and for the purpose of this note, the best thing you could do would be to open your book to page 468 to see some pictures. The pictures do, however, look very similar to what we have here. This is an electroscope. Now, it is of course important to figure out what the electroscope is and what, how big this would be, and sort of get an actual vision of what that is. If this actual device were sitting on my desk, which I have one sitting on my desk in the classroom, it's about, maybe this would be about 20 centimeters in height. 20 centimeters. And what it is a little box, a black box with clear windows. And down the middle here, you've got, this is just a conductor, where this is open, this part's open, you can get to it sort of from the outside, and this part, everything else inside the box is closed in. So you have the straight conductor here, and down each side, these fatter pieces here, these are called leaves. They're called leaves. And what they are is really lightweight conductors as well, but they're light because the way that an electroscope works is it tells you if you have charge. And you know that there's charge if the leaves are open. This says discharged, and that's why they're just hanging down, because there's nothing opposing gravity, they're just hanging. If there was electric charge on there, we would know it's charged because these leaves would open far out. And if you look lower on the page, you'll see that there's a charged electroscope picture. So, first of all, maybe we'll just define an electroscope, because an electroscope doesn't have to look exactly like this. Electroscope is any device that detects electrical charge. And that's what an electroscope is. So let's just get a vision of what's going on in this thing, the reason why we can detect charge. If I was going to look at it as it sits right now, it's neutral. There's no charge on it, and that says to me that there's an even distribution of positive and negative charges throughout the entire electroscope. Now I'm just drawing, a few positives, and I'm going to draw an equal number of negatives. An equal number of negatives, and those are representing protons. These positives are. Now, of course, there's billions and billions of protons on here, but from our perspective, what we can visualize, we'll just draw a few. What's important to know is I'm going to draw an equal number of electrons, one electron for every proton, and similar to the protons, they're sort of evenly distributed throughout the entire electroscope. And that's what a discharged or neutral electroscope looks like. Now, what happens later, and here we have our charged electroscope, what happens is if you take something that has a charge, and this looks like it has a negative charge, and I say negative, this rod here is a negatively charged rod. And I know it's negative because if I count it, I got 1, 2, 3, 4 positives, and it's about 8 negatives. So that means 4 protons and 8 electrons, representing, billions and billions. But if I brought this negatively charged rod nearby, what would happen on my electroscope? Because I've got a negatively charged rod coming here, any negatives that exist in the electroscope are going to move away. But let's first draw the positive, because it's very important to understand that positive does not move. So no matter what comes near it, what happens, I have just as many positives as I always did, and they're all approximately in the same location. But when I bring this rod that has lots of negatives on it, due to the law of electric charges, the electrons that were on here, there's going to be none more over here. They're all going to slide down to the bottom. I'm going to have the same number of them,